For most of human history, the outer edges of our planetary neighborhood were a complete blank. Astronomers stared into the dark, searching for something they could not see. In 1930, a young man named Clyde Tombaugh was examining photographic plates when he noticed a tiny point of light shifting against the fixed stars. Because this newly discovered world sat billions of kilometers away from the warmth of the sun, the scientific consensus was simple. It had to be a static, featureless ball of frozen rock. For the next 76 years, Pluto kept that exact reputation. Children memorized its name as our distant, isolated ninth planet, and schoolbooks placed it quietly at the edge of the known system. This long period of assuming Pluto was a dead, lonely rock created a blind spot, keeping astronomers from recognizing the dynamic reality waiting in the dark. In the early 2000s, better telescopes began revealing other icy bodies beyond Neptune. Scientists found an entire population of frozen remnants called the Kuiper Belt, including a distant world named Eris that rivaled Pluto in size. This photograph captures the 2006 General Assembly of the International Astronomical Union. The sudden crowding of the outer solar system forced astronomers to formally vote on what actually makes a planet a planet. This diagram illustrates the three criteria they established. A planet must orbit the sun, it must be massive enough to pull itself into a sphere, and, crucially, it must have cleared most other objects from its orbital path. Pluto easily met the first two conditions. However, because its path intersects with countless other objects in the Kuiper Belt, it failed the third, resulting in its reclassification as a dwarf planet. While the public reacted to a perceived demotion, the scientific community saw something far more interesting. Humanity had finally proven the outer solar system was a densely populated world of unmapped worlds. To truly understand this newly categorized dwarf planet, NASA launched the New Horizons spacecraft, sending it away from Earth at roughly 50,000 kilometers per hour. Even at that extreme speed, the journey crossed over 4 billion kilometers and took nearly a decade, leaving scientists to wait in suspense as the probe passed Jupiter, Saturn, Uranus, and Neptune. On July 14, 2015, the spacecraft finally approached its target. Because it was moving so fast, there was no way to stop or turn around. It was a single flyby to gather as much data as possible. As New Horizons tore past, the blurry, pixelated dots suddenly snapped into focus, revealing an incredibly complex surface. The presence of this massive heart-shaped region challenged the long-held assumption that the outer solar system was geologically dead. The close-up images revealed immense geological structures, including enormous mountain ranges rising roughly 3.5 kilometers above the surrounding terrain. At Pluto's extreme temperatures, where sunlight is more than 1,000 times dimmer than on Earth, water ice freezes so hard it behaves like solid rock, forming towering peaks. Tucked inside the giant heart is a vast plain called Sputnik Planitia, filled entirely with frozen nitrogen. This cracked, polygonal nitrogen ice is not entirely solid. It slowly creeps and flows around obstacles, creating active glaciers that drag material across the surface. Above the surface, Pluto even possesses a thin atmosphere that thickens when the world is closer to the sun and surface ices vaporize, then partially freezes and falls back to the ground as it moves farther away. As the spacecraft looked back toward the sun, it captured a faint blue haze produced by tiny particles scattering light, giving the distant world a delicate blue sky. The combination of water ice bedrock, vast flowing glaciers, and a shifting atmosphere proves a frozen world can remain geologically alive. Pluto also has a surprisingly complex neighborhood, dominated by its largest moon, Charon, which is so massive the two are considered a binary system. This animation shows their unique relationship. They are tidally locked, meaning they orbit a common center of mass in such a way that the exact same sides permanently face each other in the deep dark. Caught in the fluctuating gravity of this dance are 4 much smaller moons, Styx, Nix, Kerberos, and Hydra, that tumble unpredictably rather than spinning on a stable axis. But perhaps the most surprising detail is hidden deep underground. The geological activity on the surface suggests that internal heat and radioactive elements might be sustaining a liquid ocean beneath the ice. If a world this cold and distant can maintain liquid water, the potential locations for habitable zones within our solar system extend far beyond the narrow window near the Sun. Pluto is small, but its journey is immense, taking roughly 248 Earth years to complete a single trip around the Sun. The 2006 reclassification served as a formal realization that a world's physical size does not dictate its scientific importance. Today, New Horizons continues its outward trajectory, leaving Pluto behind as it pushes deeper into the icy remnants of the Kuiper Belt. Pluto stands as a gateway to the unknown, the first glimpse of a wild frontier stretching far into the dark.